Okay, so we we've done derivatives of polynomials, and for example, if you have a quadratic y equals x squared, then the derivative of y equals x squared, y prime. What's the answer to the derivative of x squared? Anybody? 2x. Okay? So for these polynomials and whatever, we use the power rule and all that, no? So we're gonna jump into what's the derivative of sine? What's the derivative of cosine? What's the derivative of exponential functions? And so what we're gonna do here for the first like 30 minutes maybe is prove those derivatives, so sine and cosine. And we need to know this from pre-calculus. So find the following identities and limits. So this is a identity from pre-calculus. Sine of alpha plus beta. That's the sum identity. So let me just give you what it is. No, there's a proof of this, but you're just gonna believe that this is true. Okay, so sine alpha plus beta is gonna equal to sine alpha. Did you guys do this in trigonometry? The proof, sine of alpha times cosine of beta, and then it's going to be plus cosine of alpha times the sine of beta. There's a proof of this. I have a proof of this from trig, but this is not trig. Let's go. What would be the cosine of alpha plus beta? That one is going to be cosine alpha cosine beta. The sign changes. It's not plus, it's minus. So for cosine, the sign changes. And it's good to remember cosine. There's a theme to it. Cosine starts with the C. It has a minus. Sine alpha times sine beta. These are just identities, and just believe that this is true because we're going to need it for the proofs of today. So limit as x approaches 0 of sine x over x. That's chapter 1 or unit 1. And the limit as x approaches 0 of sine x over x is 1. Again, you just have to believe all this when we start with the proof that these are true. And then the limit as x approaches 0 of cosine x minus 1 over x is 0. Okay, so hopefully you believe that this is true. All this is okay. Let's go ahead and get started with the proof. So here's the proof, not this. So what would be the derivative of sine x? See, if we have f of x equals sine x, then what is f prime of x? So what's the derivative of sine x? All right, so we're going to use that limit definition, the general one that says the limit as h approaches 0 of what? F of x plus h minus f of x over h. All right. Let's go over here. Let's go ahead and plug in the function. All right. So it's going to be the limit as h approaches 0. So wherever you see an x, you're going to plug in x plus h. So right here there's an x. Well, it's only sine x. So for x, you're going to plug in x plus h. So it's going to be sine x plus h. And then we're going to subtract the function f of x minus the function f of x is sine x. So we're going to subtract sine x over h. So we did that warm up and those identities, so we can do this expansion of sine x plus h, which is just the first one that we did, the first identity. So let's go over here. So this is going to be the limit as h approaches 0. So what was that identity? Let's remember. You have it written on your paper. It says something like, if you wrote it down, sine what? Sine, wouldn't that be alpha and that's beta? Yes or no? Yes? Somebody say yes. No? You don't believe me? Yes. Okay, thank you. One person. So alpha is x, h is beta. So it's going to be sine x. How did it go? Then after what was it? Cosine? Was it cosine? You're looking at your note. Did you write it down? Somebody? Cosine what? H, because beta is h. Mine, is it plus or minus? It's plus, isn't it? For sine, plus. Yep. Plus. Cosine what? H, wasn't it? No. Cosine what? X. Times what? Sine what? If we use sine x already, got to be sine h, yes? Yep. Minus sine x over h. So the next thing in this proof is that we're gonna put next to each other the sign here with that sign over here at the end here, and that's just how it goes. Let's go. All right, run out of space. I should wrote smaller. All right, I guess I'm gonna go down here. Okay, so limit as h approaches 0. So I'm gonna put next to each other this sine x cosine h. And then put that minus sine x right next to it. And then put this in the back over here. Over h. We have sine x cosine h minus this, so we got 3 terms. We got 1 term, 2 terms, 3 terms. I'm gonna keep these together and then divide it by h, and then I'm gonna keep this by itself divided by h, separate them. That is allowed. It's fine. So what I'm gonna do is this: limit as h approaches 0. Of sine x cosine h minus sine x over h plus, okay, let's go step by step. So it's the whole quantity and I'm separating it, plus this divided by this. So this is true. This is equal to that. That's true. Okay, so now we're just gonna go and do the limit of each one of these. This one and this one. All right, so run out of space, so I have to erase and then start over here again, continue on, because we don't have any space. All right. So, I'm going to take the limit of this and then the limit of that. But you could already see that here I can factor out sine x out of these two terms. So that's what I'm going to do. So this is going to be the limit as h approaches 0 of sine x cosine h minus 1 over h and then I'm going to add the limit as h approaches 0 of cosine x times sine h over h. So this is the limit as h approaches 0. So this is about h, all these h's. So this sine x is almost like a constant. So that one can come out of this. So that's what I'm going to do next. I'm going to factor out of this sine x. And then we're also going to factor out this cosine x because this is h approaches 0. That's for that. So we're going to do cosine x lim h approaches 0 of sine h over h. So what were the limits that we had those two limits? Didn't we have those limits where we had the limit as x approaches 0 of cosine x minus 1 over x? What was that? Did anybody write down the notes? The difference is that we don't have x, we have h. So the one that we had in the warm up, it was x approaches 0 of cosine x minus 1 over x. What did that limit? What was that limit? 0. Thank you. The only person came late says it. 0 times sine x is what? 0 times anything is what? 0. So this is 0. And what was this? Look at your notes. It's 1, was it? Because x approaches 0, sine of x over x, wasn't it? So it's going to be 1 times cosine x. So it's going to be cosine x. So what's 0 plus cosine x? You don't even need 0. So the answer is what? So the derivative of sine x is what? Cosine x? That's enough. Hopefully you don't want to go through all this with the derivative of cosine, do you? So the derivative of sine x is cosine x. I took about 15 minutes to tell you and prove it that the derivative of sine is cosine. I don't think you want to go through all this with every single one of them. So I'll leave it to you to take a look at it. And I'm going to go on with what the derivative of cosine is. I already told you guys when it starts with a c, any of these trig functions that start with the letter c will have a negative derivative. So the derivative of cosine x is going to be, I'm not going over this because we got too much to do today. The derivative of cosine x is what? What's the derivative of cosine x? Somebody. What's the derivative of cosine x? Negative sine x. Thank you, Anthony. Derivative of cosine x is negative sine x. Which, I don't think you want to go through that proof of this. All right. So let's go ahead and do number one. Problem number one. Find an equation of the tangent line to the graph of f of x equals cosine x at x equal pi by 2. Have we not done these kind of problems a ton already? So many. Find the equation of the tangent line to that. So now we're doing it with trig functions. So it's going to be y minus x minus so what do I plug in after x minus? Pi over 2. The y value was not given, so you have to evaluate that. What's the cosine of pi by 2? 0. So 0. And for those that don't know what cosine of pi by 2, I included the unit circle. We're going to go over the unit circle after this one, I think, after this. Because I'm going to show you a trick on how to do this. Cosine pi by 2 is 0. And now we're doing the calculus of finding the derivative of pi by 2, which is then we have what? F of x. F of x is equal to cosine x. F prime of x. What's the derivative? It took 15 minutes. If you don't even know why I do that 15 minutes, so you know that derivative of cosine x. Oh, no, we didn't do that. We didn't prove that cosine x. But what's the derivative of cosine x? We did the proof of sine x. What's the derivative of cosine x? Negative sine x. Now we can evaluate it at pi by 2. F prime of pi by 2. So f prime of pi by 2 is going to equal to negative sine pi by 2. What's sine of pi by 2? That's what we got to do here first. Sine of pi by 2. What's sine of pi by 2? 1. So it's going to be what? Negative 1? Yes? So negative 1, and we're done. All right, here we go. Look, draw this. Let's go. Let me review trigonometry with you right now. Yes, now. What you should have learned in pre-calculus in about 2 weeks or something it takes. I'm gonna go over it in 20 minutes, less than 20 minutes right now. Everything you need to know. So draw a circle as best you can, and I'm gonna derive all these numbers around the circle. First, you have to believe some truths about this that I hope you believe. Okay, let me see. I'm trying to get to where is it that I can get you so you believe what we're gonna do here. How many degrees? Let's go back to degrees. How many degrees is around a circle? How many degrees is that? Man, if it's not everybody saying 360. Yes or no? So around is 360. So then what would be halfway here? 180. Do you believe what I'm saying? Man, I'm serious. So 360 is all the way. You heard it. We did a 360. 360. This better be 180. But we're not doing degrees in calculus. We don't do degrees. We do radians. So how do we find radians? What are radians? Radians are this. Look, if I get a string and I go from there to from here to here, it's called the radius. I think that's what it's called. And if I get a string and I go around the circle, how many of these radiuses will I be able to make? How many of these? I'll grab it and I'll go around the circle. It'll make one length, say, I don't know because I don't have the string, but say that's one. It'll make another one maybe here, and then a third one maybe all the way to here. But then there's always going to be a little bit missing. How much do you think is missing all the time? Good job. You guys say 0.1416 on. Do you know what I'm talking about? Yes, you are. It's pi. Yes or no? You say yes. So now, if you believe that, what I just told you, then we can derive all these these angles in radians. If I don't go all the way to pi, but I just go halfway, what would be right up here? That's very smart, because that would be half of pi. Wow, that is smart. That's pi by 2. If I cut this pi into quarters, again, 4 little pieces, 1, 2, 3, 4. What do you think is going to be this one? I think it's going to be pi over 4. Makes good sense to me. Yes or no? Pi over 4 here? So if that is pi by 4, okay, now, this is the way we're going to do it, okay? So we can derive all these. If I, instead of doing this pi by 4, I want to do this one, and why do I want to do this one? What do you think this one's going to be? In degrees, which one do you think this one is? Some random one, or do you think there's a special one that I'm trying to get to here? It's 30 degrees is correct. Good job, 30. Because I'm looking at 30, 60, 90 triangles, and that's what I want. So if this is 30, that'll be 30, 60, 90. That'll be cut into 6 pieces. 1, 2, 3, 4, 5, 6. So 180 divided by 6. What's 180 divided by 6? You guys got calculators. What's 180 divided by 6? 30. So if I say pi is 180, and I'm dividing this by 6, that makes it 30, then this will be pi by 6. Okay. 30 degrees is pi by 6. And if I do 180 divided by 3, what do you think is 180 divided by 3? And the one that, since I said that pi is 180, pi by 3. Pi by 3. This one's pi by 3. And you know what? I learned from students. A lot of the things, the way I teach it, and it's from experience from students that I get these ways of teaching and the way I think about it. Because they told me about it. It wasn't me. I get some students that are really bright in the way they look at it. So what was it? I said this is pi. And I want to get the rest of these around the circle. Then what I'm going to do is this. See, I can go ahead and I got a whole pi. If I go around, I have a whole pi. But if I just want to get to this one here, let's say this one, is that I'm going to go ahead and get a whole pi and subtract this pi. Because then we always start here and we go like this. So then this is going to be a whole pi, take away a pi by 6 to land here. So it'll be pi minus pi by 6. So now I can just make it a fraction, 1 over 1, that'll be 6 over 6 in equal pieces. So you're subtracting, because you have a common denominator, 5 pi by 6. So the way to do these ones here is that you're just going to subtract this number in front of pi from the bottom. So 6 take away 1, 6 minus 1, 6 minus 1 is 5 pi by 6. 5 pi by 6. So if I want to get this one over here, it will be 4 minus 1. 4 minus 1 is 3 pi by 4. The one over here will be 3 minus 1 is what? 3 minus 1 is 2 pi by 3. 2 pi by 3. This will be 2 pi by 3. And to get these ones across over here, you're actually adding instead of subtracting. Why? Because you would have a whole pi, and you're going to add this piece here, this piece, that is this piece here. So you're adding a pi, you're adding another, see, you got this pi plus this would give you this. So that would be, instead of subtracting, you're just adding. So it'd be what? Pi plus pi by 6. And so what would it be? That's 6 over 6. 6 plus 1, 7 pi by 6. So basically we're going to do what? 6 plus 1 instead of subtracting. What is 6 plus 1? So this one would be what? 7 pi by 6? This one would be what? What is 4 plus 1? 5 pi by 4? This would be 5 pi by 4. And this one over here would be what? 4 pi over 3. This is so dumb. So patterns, it's just pattern recognition. So what is then, what's 2 plus 1 is what? It's going to be what? 3 pi by 2? And also here, to get these ones here, is that you already have this much. You have 2 pi by 3 that you're going to add a whole pi to it to get here. So basically you're adding the bottom to the top. 3 plus 2 is 5 pi by 3. This one's going to be 5 pi by 3. This one's going to be 7. 4 plus 3, 7 pi by 3. 7 pi by 4. And this one's going to be 11 pi by 6. So let me do a summary of what I just said. You have to believe that this is pi is 180. That is half of pi. Pi by 6, because you cut it into 6 pieces. Pi by 4, pi by 3, pi by 2. I'm going to get this one quickly. I can get this one by saying that this is related to this. You see how this one goes? It's going to go like this. That's going to be 4 pi by 3. Did I subtract or add? Subtract 2 pi by 3, my bad. 2 pi by 3. This one's going to be what? Help me out, because I can't add or subtract. What's this one? 3 pi over 4. What's this one going to be? The only that subtracts from there is this one. So this one's going to be what? 5 pi over 6. The rest, they all add. 6 plus 1 is 7 pi by 6. 5 pi by 4. 4 pi by 3. 3 pi by 2. If I got this next one here, it's going to be what? 5 pi by 3. 7 pi by 4. 11 pi by 6. If this is a length of 1, if this is like, that's why it's called a unit circle. If this is a length of 1, then this x value is 1. And it's not the point. We're talking about this point. It's at y equals 0. If this is a length of 1, then x is what? It didn't move on the x. That's going to be what? And then y is? This one's going to be what? X is the length. It went to what? -1, didn't it? And the y is? This is what? X is what? Didn't move on the x? And on the y is what? You remember this from pre-calc? Does he teach it like in some way like that, or he cuts it? Everybody mostly cuts it, and they do like this and then this and they I don't know, but we just want to remember this fast and quick. All right, now here's the trick. I'm gonna give you another trick. How do you get the actual answers for these ones here? And I'm going to tell you, then again, I took this one not from a student, but from somewhere else, just barely like a couple years ago. Everybody, how we get the answers to this sine of pi by 6, cosine pi by 6, tangent pi by 6? Go ahead and write that down. Everything is going to be over 2. Go ahead and do everything over 2. Everything over 2. and we start like this. Look, this is so like, I'm not even thinking. I just got to remember some things, and after that, I fill this out quickly. I have to remember that I start from the top left right here. And we start with 1, and we take a square root of 1. So I'm not even, what's the square root of 1? Because we take the square root of 8. What's the square root of 1? 1. The square root of 1 is 1, so you automatically put a 1. The square root of 2 is some decimal, so it's going to be square root of 2, leave it at square root of 2. Square root of 3 is some decimal, square root of 3. And we go back up, turn around. Square root of 1, what's the square root of 1? What's the square root of 2? Square root of 2. This is square root of 3. You start from the top left, square root of 1, go down, and go back up. And I filled this out already. And now, how do I get the rest of these? Well, we know that on the x is negative on the left. So all the x's are going to be negative. All these ones are going to be negative, where the y's are going to be positive because on top. All right? Watch. Man, I should charge so much money for this. The y's are negatives. I mean, the x's are negatives. The y's are positive. All you got to do is just, all these x's are negatives. The y's are going to be positive. It's symmetry. Whereas here, on this one, all of them are negative. Because this is negative, so all the answers are negative. So, this one's going to go here. This one's going to go here. This one's going to go here. And they're all negative. And this one's going to go here. And they're all negative. And yet you can get these ones. Those go down here where only the y's are going to be negative because the x is positive here. So all the x's are positive, the y's are going to be negative. Okay, now I have filled out the unit circle. Cool, what? So now you're gonna say like, so what's the point of, or what do we do with this? All right, watch. I'm gonna show you. If you have this, if you really understand this, then you don't need a calculator. I mean, you can verify some of these answers. Some of you, I don't believe this. Okay, sure. Look, go get a calculator and do sine of, what is sine of 7 pi by 6? What is sine of 7 pi by 6? Sine of 7 pi by 6 is negative 1/2. Put it in a calculator if you want. I know it's going to be negative 0.5. All right. Let's go number 2. Let's go to problem number 2. A couple of years, I'm just going to be a tutor. Some tutors, some calculus tutors charge $100 an hour. Dude, I'm gonna charge more, and I just work 3 hours, I'll be done. So one more time, you have to be able to get what is the function, and then what, cheat on this, no? So what is the function, and at what point is it being evaluated? That's what we need. So what is f of x? Sin x is correct. Sin x. And then it's being evaluated at a equals what? Seven pi by 6. So easy. What is f prime? What's f prime of x? That one I took like 15 minutes. Is cosine x? Cosine x. And now I'm going to evaluate f prime at 7 pi by 6. Cosine of 7 pi by 6. And so you're over here on the AP exam and you're like, I don't know how to do I don't know. I never learned cosines and sines and. So let me show you. Oh, that's ugly. No, undo. Look, I'm gonna show you how to do this so easy. So I'm looking at over 6. So it's related to something over 6. So I got this in my head. Over 6, that's 180 divided. That's 30 degrees. 30 degrees is this one. 30 degrees, this is pi by 6. So this is pi by 6. And then, so it was like that, and it was like that. It was over 2, over 2, over 2. Over 2. Okay, so over 2. Everything over 2, and it was 1, 2, 3. Oh, root 3 over 2. And I got what? Over 2. And then I start 1/2. And I'm doing cosine 7 pi by 6. So it's going to be, add the bottom to the top. It's going to be over here. I'm doing cosine. So it's going to be this one, but it's going to be negative root 3 over 2. While everybody's getting their calculators and trying to figure it out with the it's got to be negative root 3 over 2. You don't get it? Huh?
It shouldn't be square root 3 over 2.
It shouldn't be?
It shouldn't be 3. I think it's square root 3.
So what I had said was, I don't know, it goes like that, it goes like this, and somebody's saying that they're like, no, it's not. So how did it go? Let me erase this and then start over. Somebody's not believing my stories. What I had said was, everything over 2, everything over 2, everything over 2, everything over 2, and I said that it goes something like, start at the top, square root of 1 is 1, so it'd be 1, square root of 2, square root of 3 over 2, and I'm looking at cosine is x, and then I'm here, but then cosine is negative over here, and it stays negative. It's negative root 3 over 2. What?
That's what it said. I think it's 33.
So let's move on now to 2.7, derivative of exponential functions. So how can we figure out what the derivative of an exponential is, an exponential function? So what would be the derivative of e to the x? Oh, are we going to do this? I'm going to do a proof of this. Are we going to do a proof? Yes, let's do the proof. So let's use the limit as h approaches 0 of f of x plus h minus f of x over h. So it's going to be the limit as h approaches 0. And we're going to plug in for wherever you see an x, you're going to plug in x plus h. So there's an x here at the top, so it'll be e to the x plus h minus f of x, where f of x is e to the x over h. So these are properties of exponents. Let's go. What is e to the x plus h? How can I rewrite that? E, say for example 3 plus 2, because x is 3, h is 2. Let's not even go with e. Let's go with like 2 or something, base 2. So isn't this 2 to the 5th? Isn't it 2 to the 5th, no? That's 2 to the 5th. Could we rewrite this and say it's 2 to the 3rd times 2 to the 2nd? Could we? Yes or no? Because 3 plus 2 is 5, 2 to the 5th, that is correct. Or I can just go 2 to the third times 2 to the second. Why? Because 2 to the third is what? 2 to the third is what? 8? And then 2 squared is 4. That's 32, no? And then 2 to the fifth is 32. So yes, we can. Let's go ahead and do that then. So we can separate lim h approaches 0, e to the x times e to the h minus e to the x over h, which is going to be equal to lim h approaches 0. What can I do at the top? What can I do at the top? Factor out e to the x. Factor out e to the x. And because again, like I said in the one proof of sine, that is h approaches, h, that e to the x is just becomes almost, it's a constant. So then I have e to the x outside, e to the x, and then times it by lim h approaches 0, e to the h minus 1 over h. And here's where we have a problem. Why do we have a problem? Because if we do plug in, h is 0, and plug in here, h is 0, then I'm going to get e to the 0. What is e to the 0? And that would be 1 take away 1 is 0 over 0, which is indeterminate. Yes, we got a problem here. So how do we continue on with this? We're just going to have to just do a table. That's what we're going to do now. Because this is kind of a problem, and so let's just figure out what is the limit by doing a table. All right, so here. So we're here. That's where we're at. Let's do a table to just figure out what this is right here. So we want to get as close as possible to 0 of h. So what numbers am I going to choose? I'm going to choose like 1. Am I going to use 1 first? And then 0.01, 0.001, and like that? No, I start with 0.1. So we're already starting really, really close. So we plug it in. Get your calculators. That's what we're doing. That's why I gave you calculators, aside from everything. E to the 0.1 minus 1, e to the 0.1 minus 1 over 0.1. So go ahead and give me that answer. What's e to the 0.1 minus 1, if you want to put 0.1, e to the 0.1 minus 1 over 0.1, what is that? E to the 0.1 minus 1 divided by 0.1. Anybody, what is it about? 1.05. All right, 1.05. Let's go with 0.01. Let's plug in 0.01. Anybody, what are you getting for 0.01? 1.005. Oh man, I don't know. Let's go. Well, let me give you, because you got to move on. .001 is going to give you that, .0001 is going to give you that, and .00001 is going to give you what? Let's finish, write those numbers down, and let's finish up with that .00001. What if we do negatives .00001? What would that be? That's a good question. Hey, why don't you guys do that one? I just thought about it right now. What would it be also if you do negative .00001? Anybody? What'd you get for this one, though? It's going to be safely that you can say that the limit is what? The limit is 1, okay? The limit is 1. But I want to see what is it when you put a negative .0001. What are you getting? Is it still the same? Is it it has to be the same. It has to be the same answer. Because that's the definition of the limit, the derivative. It has to be from the left and from the right. What are you getting? When you plug it in, huh?
0.9999.
So it is approaching it. All right. From the other side. Therefore, if we say that this is what? This is becoming what? 1, no? So it's going to be 1 times e to the x. So what's the derivative of e to the x? E to the x is itself. The derivative is itself. These 3 little dots right here for people, this is called therefore. Therefore, f prime of x is equal to e to the x. And then there's this other one that you, again, just believe it. It's the proofs and why it's true. It's in the future. Consequently, this is also true. The derivative of e to the u, where u is some other function, it would be e to the u, and the derivative of that function u, whatever that is, times it. So it's going to be the derivative of that function times e to the u. And we'll do some examples of this in a minute. All right, let's go. Okay, well, here it is. There it is. Find the derivative of this. See, here is where we got this other function. U is going to equal to 2x plus 4. So that formula, or that derivative, it says that it's e to the u, they put it in the front, times u prime. So we have to take and put it right here in the back or in the front, the derivative of this. I guess you could put it in the front. So the derivative of an exponential is e to the whatever it is, 2x plus 4. But you got to take the derivative of that thing. So what's the derivative of this? 2. That's it. We're done. All right, let's go. Continue. Number 4. So exponential, for an exponential, is just e to the x squared. And the derivative of x squared is what? The derivative of x squared is what? Five. Let's go to number 5. So it is an exponential. X to the third is, it looks weird, but you could just say it's 1/3 x. And the derivative of 1/3 x, what's the derivative of this? This isn't 1/3? So it's just be 1/3 e to the x over 3. What happened there? Let's go to number 6. E has a earring. Nobody gets like E has a, like, oh, you guys don't see it? It has like a little earring here. You don't see that little dot right there? You don't see the dot? You don't see this dot? Look, there's a dot right there. Anyways, let f of x equal to that. Find f prime of x. So what's the derivative? The derivative?
E to the x subtract 1.
7. Let's go to number 7. Separate, divide x into that and into that. And I'm already going to put what? X to the 1/3? Yep, x to the 1/3 over x minus 2x to the e to the x over x. So this is going to be f of x equals, what's 1/3 minus 1? Because we're subtracting 1/3 minus 1. What's 1/3 minus? Is that negative 2? Negative 2/3. And then this, you can cancel out these x's. So it'll be minus 2 e to the x. And now we can take the derivative of that, f prime of x. And that's going to be what? Negative 2/3. And then minus what? Minus 3 over 3, which is minus 5/3. And then what? Minus 2 e to the x. And this got to go to the bottom. This should be almost like final answer, but on a multiple choice, they usually put this negative 2/3. And then maybe they even do this, 3rd root of x to the 5th power, maybe like this. And then minus 2 e to the x. You just got to be able to see how they rewrite it, in which way they have it. Did I? Yeah. All right, we're almost done. Lesson 2.7, derivative of log functions. If y is equal to ln x, then what is dy dx? this one, you absolutely will have to, comes up a whole lot. ln x, the derivative of ln x. We'll do a proof next week sometime. We'll prove that why this is true. So what do you guys think the derivative of ln x is? And the answer is 1 over x. The derivative of ln x is 1 over x. All right, number 8. So 5 is just a constant. So that was just whatever, okay? Then we can take the derivative of ln x. So you can go 5 factor or take it out. I'm already, oh, hold on, undo, ln x. So what's the answer? 5 over x, 5 over x. Okay. So for any exponential function that is not e, so say y equals 2 to the x, I don't know why, but on the AP curriculum, they don't emphasize this at all. What's the derivative of some exponential with the base 2, 3, or whatever? But the answer to this, we'll do the proof of this. It'll just be what? Y equals, so then d dx of this, of it's going to be just that, b to the x times ln of b of the base. So the derivative of something like that, and so if I do y equals 2 to the x, the derivative of this would y prime will equal to 2 to the x times ln 2. I hope I'm right. We're actually copying wrong things. Let's see. Yeah, so it's b to the x times ln of the base. They don't really test this much, but I don't know. I guess we'll just. Let's go then. Number 10. So it should be what? 2 sine, what the heck? Undo. 2 sine x times ln 2. But let's not forget about the derivative of that. What's the derivative of sine x? So that should be the answer right there. Yep. Yeah, they're right there. Different. So if y equals log base b of x, then dy dx is what? So if you got some not natural log, not ln x, because that one's very special. If we got something like y equals what? Log base 2 or something like that of x, what's the derivative of that? So what would be y prime of that? So instead of putting it right in the front or the back on top, it's going to be divided by. So whenever you do a log, it's gonna be divided by. Okay. Well, what the heck is it then? All right, what is it? It's 1 over x ln b. So I guess it's like ln that you do have 1 over x, but then everything's at the bottom. Then everything's at the bottom. Then so if this is true, then this should be 1 over x. 1 over x ln ln2. Is it ln of the base? Let's see. Is it? So this should be, if we're doing this, log base 4 of x should be 1 over x ln of 4. We're almost done. We'll do this one maybe, and maybe one more, that's it. 12, when x equal 2e, lim h approaches 0, that thing is what? So we got to be able to find the function and evaluate it at whatever it is, a. So what's the function? Ln x. And it's evaluated at what? 2e. So what? F prime of x is what? F prime of x is what? 1 over x? What? Is 1 over 2e? Let's go. Last one. This last one. Yeah, they're so repetitive sometimes with this. If f is the function given there, what is the equation of tangent line? Da, 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 da. So what's the derivative? Oh, you guys,
1/3
can we just evaluate it at what, 4? Oh, no, hold on, what did I do? What did I do? Did I get this wrong? No, yeah, I'm doing it wrong. Undo. F prime, we're valuing at 3 ln4. 1/3 e to x is 3 ln4 over 3. What can we do now? Cancel this out. We'll go step by step. 1/3 e to the ln4. Then what? Don't these cancel out? Huh? Don't they? Yes. They're opposites. So they cancel out. So be what? 1/3 times 4, which is? Yes. You can do that if you want. Take a look at it.